Antarctica is the fifth largest continent on Earth, covering more than 5 million square miles. That's nearly twice the size of Australia and larger than Europe. Imagine flying over an expanse of white that seems endless, stretching beyond the horizon in every direction. Unlike other continents, Antarctica has no countries, no cities, and no native human population. It's a world ruled by ice and wind, where nature exists in its purest, rawest form. Located at the very bottom of our planet, it's surrounded by the vast Southern Ocean, a turbulent and icy body of water that isolates it from the rest of the world. This isolation has kept Antarctica pristine, untouched by modern civilization for millennia. The continent is divided into two major regions: East Antarctica, the larger and more elevated part, and West Antarctica, which is smaller but more geologically active, home to subglacial lakes, deep ice-covered valleys, and even hidden volcanoes beneath the ice sheet. But what makes Antarctica so extreme? To understand that, we have to look at three key factors: its cold, its dryness, and its wind. Let's start with the cold. Antarctica is the coldest place on Earth, holding the record for the lowest temperature ever recorded, -128 degrees Fahrenheit at the Russian Vostok station in 1983. That's colder than dry ice, which sublimates at -109 degrees Fahrenheit. But here's something even more mind-blowing. In 2018, scientists using satellite data discovered an even colder spot in the interior of East Antarctica, which is 144 degrees Fahrenheit. That's getting close to the surface temperature of Mars. At these temperatures, survival is almost impossible. Any exposed skin would freeze in seconds. If you were to take a deep breath, the moisture in your lungs could crystallize instantly, causing extreme pain and difficulty breathing. Cars, generators, and even scientific equipment have to be specially designed to function in these conditions. For researchers working at places like Vostok Station or the South Pole, stepping outside requires multiple layers of insulated clothing, specialized boots, and protective goggles. Without them, frostbite can set in within less than a minute. The extreme cold isn't just a challenge for humans. It affects the very landscape itself. Most of the ice in Antarctica is ancient, hundreds of thousands to millions of years old. The deep ice sheets hold clues about past climates, acting like a frozen time capsule that scientists drill into to study Earth's climate history. Trapped inside are tiny air bubbles from past atmospheres, allowing researchers to analyze how CO2 levels and global temperatures have changed over millennia. But what about the people who live here? Well, no one truly lives in Antarctica permanently, but there are around 1,000 to 5,000 people, scientists, engineers, and support staff, working at various research stations throughout the year. During the summer, when temperatures are slightly warmer, around 14 degrees Fahrenheit to 32 degrees Fahrenheit, scientific operations are at their peak. But in the winter, when darkness lasts for months and temperatures plummet, only the most dedicated and prepared scientists remain. When we think of deserts, we usually picture endless sand dunes under a blazing sun. But deserts aren't defined by temperature. They're defined by precipitation. And in Antarctica, precipitation is shockingly low. In some places, as little as 50 millimeters per year. That's drier than the Sahara Desert, one of the driest places in Antarctica, and indeed on Earth, is the McMurdo Dry Valleys. This region, which spans 1,850 square miles, hasn't seen rain for nearly 2 million years. The landscape here is otherworldly, barren, rocky, and devoid of ice, despite being surrounded by glaciers. The reason? The katabatic winds are so strong that they evaporate all moisture, leaving behind an eerie, Mars-like terrain. Scientists study the dry valleys because they closely resemble environments found on Mars and other planets. NASA has used this region to test rovers and study how microbial life can survive in such an inhospitable place. Microbes found here live inside rocks, getting just enough water from microscopic ice crystals. If life can survive in Antarctica's driest valleys, could it exist on Mars or Europa, one of Jupiter's icy moons? If you thought Antarctica's cold and dryness were extreme, wait until you hear about the winds. This is the windiest continent on Earth, with gusts reaching up to 200 miles per hour, stronger than most hurricanes. These winds are known as katabatic winds, and they're unique to Antarctica's geography. So what causes them? It all starts with Antarctica's immense ice sheets, which are thousands of meters thick. Cold, dense air forms over the interior and begins to sink due to gravity. As it descends, it picks up speed, rushing down the slopes of the ice sheets toward the coast, creating hurricane-force winds. The force of these winds is so intense that they can blow people off their feet, flip over vehicles, and even move large blocks of ice across the frozen landscape. One of the windiest places on Earth is Cape Denison, where the average wind speed is around 50 miles per hour and gusts frequently exceed 150 miles per hour. Imagine stepping outside into a wind that feels like a battering ram, making it impossible to walk forward. These winds also play a crucial role in shaping the landscape, sculpting the ice into sharp ridges known as sastrugi, which resemble frozen waves. But katabatic winds aren't just destructive. They also have a hidden benefit. In some areas, these winds create ice-free zones by continuously blowing away snow and ice, exposing the land beneath. These exposed areas provide valuable sites for scientific research and even rare habitat for some microscopic life forms. Antarctica is truly a land of extremes. It is the coldest, driest, and windiest place on Earth, pushing the limits of life and human endurance. This frozen continent remains one of the most mysterious and least explored regions of our planet. But despite its harsh conditions, it holds secrets that could unlock our past, help us understand our present, and prepare us for the future. And this is just the beginning of our journey through Antarctica. Long before Antarctica was officially discovered, it existed only as a myth, a legend that fascinated scholars, sailors, and mapmakers for centuries. Ancient Greek philosophers, including Aristotle and Ptolemy, believed that a vast, unknown land must exist at the bottom of the world. They called it Terra Australis Incognita, means the unknown southern land. Why did they believe this land had to exist? The reasoning was based on an ancient idea called the theory of symmetry. Early geographers thought that for the world to be balanced, there must be a massive continent in the south to counter the known landmasses in the north. Though entirely speculative, this idea persisted for nearly 2,000 years, influencing world maps well into the age of exploration. European explorers in the 16th and 17th centuries searched for this mythical land, convinced it was rich with resources. Sailors ventured further south than ever before, encountering icebergs and treacherous seas, but no one found the vast continent they expected. The southernmost known lands at the time were the Tierra del Fuego archipelago, New Zealand, and Australia, but Antarctica remained elusive, hidden beneath a fortress of ice and brutal weather. It wasn't until 1820 that Antarctica was finally seen by human eyes. 3 separate expeditions are credited with the first confirmed sightings, each within days or weeks of each other. The race to discover the last continent was on. On January 27, 1820, Fabian Gottlieb von Bellingshausen and Mikhail Lazarev, 2 Russian naval officers, became the first recorded people to see the Antarctic ice shelf. Sailing aboard their ships, the Vostok and Mirny, they observed what is now known as the Fimbul Ice Shelf in East Antarctica. Though they didn't set foot on land, their sighting officially put Antarctica on the map. Just 3 days later, on January 30th, 1820, Edward Bransfield, an officer in the British Royal Navy, also spotted the Antarctic Peninsula, adding to the evidence that a vast continent lay beyond the icy waters. That same year, Nathaniel Palmer, an American sealer, claimed to have seen the land as well. But seeing Antarctica was one thing. Landing on it was another challenge entirely. While Bellingshausen, Bransfield, and Palmer may have seen Antarctica, none of them actually set foot on its frozen shores. That honor likely belongs to an American sealer named John Davis. On February 7th, 1821, Davis and his crew, searching for new hunting grounds, landed at what is now believed to be the Antarctic Peninsula. In his ship's log, Davis wrote that he and his men went ashore, found it barren, and took nothing of note. At the time, this event didn't seem significant. Seal hunters weren't interested in making history, only in finding seals. But in retrospect, This moment marked the first recorded human presence on the most remote and inhospitable continent on Earth. Fast forward to the early 20th century, and Antarctica was no longer just a place of mystery. It was a prize to be conquered. The greatest challenge? Reaching the South Pole, the most desolate point on the continent. This quest would spark one of the most famous rivalries in the history of exploration, Roald Amundsen versus Robert Falcon Scott. Roald Amundsen, a Norwegian explorer, was a man obsessed with precision and efficiency. He had already proven himself by navigating the treacherous Northwest Passage in the Arctic, but now he had his sights set on an even greater challenge. Initially, Amundsen planned to reach the North Pole, but upon learning that Americans Robert Peary and Frederick Cook had already claimed that victory, he secretly redirected his mission south, without informing his sponsors or even his crew until they were well on their way. Amundsen was a meticulous planner. He studied Inuit survival techniques, adopting their use of sled dogs and fur clothing, which proved far superior to the wool and leather gear used by European explorers. He designed a strategy based on small, fast-moving teams, relying on careful food caches and methodical progress. On December 14, 1911, Amundsen and his team became the first humans to reach the South Pole. They planted the Norwegian flag and left behind supplies and a letter for Scott, should he arrive later. Then, in a display of sheer efficiency, they turned back and made it safely to base without a single casualty. Amundsen's journey was a masterclass in planning, execution, and survival. Robert Falcon Scott, a British naval officer, approached the challenge differently. He was a determined leader, but his planning was flawed. Unlike Amundsen, Scott relied on ponies, which struggled in the extreme cold. He also brought motorized sledges, but they broke down early in the journey, forcing his men to pull their own sleds. Scott's team, burdened by heavy loads and poor logistical choices, moved much slower than Amundsen's. By the time Scott and his exhausted men reached the South Pole on January 17, 1912, they were devastated. Amundsen had beaten them by over a month. Demoralized and ill-prepared, Scott and his team faced a grueling return journey. Starvation, frostbite, and exhaustion took their toll. One by one, the men perished in the ice. Scott's final diary entries, written as he lay freezing in his tent, are heartbreaking. His last recorded words, "For God's sake, look after our people." Months later, a search party found Scott's frozen body, along with the bodies of his remaining men and his diary, detailing their final days. The tragic fate of Scott's expedition turned him into a national hero in Britain, a symbol of courage, sacrifice, and the brutal reality of Antarctic exploration. The discovery and early exploration of Antarctica was a test of human endurance, ambition, and survival. From the first speculative maps to the daring expeditions that revealed its true nature, this frozen land has always been a place of mystery and challenge. Amundsen's victory proved that careful planning and adaptation were the keys to success in such an extreme environment. Scott's tragic failure, while heartbreaking, served as a lesson for future explorers. Antarctica is unforgiving, and only those who respect its power can survive it. But this was just the beginning. In the decades that followed, new explorers, scientists, and adventurers would push even further into the heart of this icy wilderness. The mysteries of Antarctica were far from over. In the next section, we'll uncover the hidden world beneath the ice, ancient secrets, undiscovered life, and the clues that Antarctica holds about our planet's past and future. At first glance, Antarctica may seem like a barren, frozen wasteland, a place where no life could possibly survive. But against all odds, this icy wilderness is home to some of the most extraordinary creatures on Earth. From the depths of the frigid Southern Ocean to the vast, snow-covered ice sheets, life in Antarctica is a masterclass in adaptation and resilience. Every animal that calls this place home has evolved remarkable ways to endure the cold, the wind, and the isolation. Some creatures stay here all year, braving the darkness of the Antarctic winter, while others migrate from thousands of miles away, taking advantage of the rich, icy waters during the summer months. Today, we're diving deep into this frozen kingdom to uncover the secrets of Antarctica's incredible wildlife. No creature is more synonymous with Antarctica than the penguin. These flightless birds have evolved to become some of the most efficient swimmers on the planet, replacing wings with powerful flippers and developing thick layers of fat to keep them warm. Let's start with the most legendary of them all, the emperor penguin. Standing nearly 4 feet tall and weighing up to 40 kilograms, 88 pounds, emperor penguins are the largest of all penguin species. They are also the only species that breeds during the Antarctic winter, enduring months of total darkness and temperatures that can plummet to minus 76 degrees Fahrenheit. Their survival strategy is both simple and brilliant, huddled together. Thousands of male emperor penguins crowd into tight groups, rotating positions so that no individual spends too much time exposed to the freezing air. This teamwork allows them to maintain warmth and survive conditions that would be fatal to nearly any other creature on Earth. But perhaps the most astonishing feat of the emperor penguin is its dedication to parenting. After the female lays a single egg, she hands it off to the male, who carefully balances it on his feet, tucking it under a flap of warm skin called a brood pouch. For the next 4 months, the male will go without food, surviving only on stored body fat while braving the harsh winter. Imagine standing still for months in sub-zero temperatures, not eating, all to protect the next generation. When the chicks finally hatch, the mothers return from the sea, full of food, and take over parenting duties while the exhausted fathers finally get their chance to eat. It's a survival story unlike any other in the animal kingdom. In contrast to the stoic and resilient emperor penguins, the Adelie penguin is a lively, playful, and highly social species. These smaller penguins, standing at just 2 feet tall, are expert swimmers, reaching speeds of up to 15 miles per hour, 24 kilometers per hour, in the water. They rely on this speed to outrun predators, such as the fearsome leopard seal. One of their most fascinating behaviors is their nest-building strategy. Instead of burrowing or relying on soft ground, Adelie penguins gather small stones to form nests. However, in true penguin fashion, they don't always collect their own. Many resort to a bit of penguin thievery, stealing stones from their neighbors' nests in a never-ending cycle of deception and defense. During the Antarctic summer, massive colonies of Adelies, sometimes numbering in the hundreds of thousands, take over the rocky coastline, creating a chaotic, noisy, and vibrant scene. They are energetic, curious, and unafraid to investigate new things, including human explorers. But penguins aren't alone in this frozen world. The Antarctic ecosystem also boasts some of the most powerful and efficient predators on Earth. Let's meet 2 of the most formidable hunters beneath the ice: the leopard seal and the Weddell seal. Sleek, powerful, and deadly, the leopard seal is the apex predator of Antarctica's waters. Unlike most seals, which feed primarily on fish and krill, leopard seals are fearsome hunters, specializing in hunting penguins. These skilled ambush predators lurk beneath the ice, waiting for an unsuspecting penguin to dive in. With lightning-fast reflexes, they snatch their prey, thrashing it violently before swallowing it whole. Reaching up to 12 feet 7 meters long and weighing over 600 kilograms, 1,300 pounds, they're among the largest seal species. Their powerful jaws and razor-sharp teeth allow them to even hunt other seals, making them one of the most dominant predators in the Antarctic food web. While the leopard seal rules the surface, the Weddell seal dominates the deep. These remarkable creatures are record-breaking diverse, capable of plunging to depths of 600 meters, 2,000 feet, and holding their breath for over an hour, longer than nearly any other mammal. Their secret? A special adaptation called myoglobin, a protein in their muscles that allows them to store extra oxygen, making long dives possible. This ability allows Weddell seals to navigate beneath the Antarctic ice, hunting for fish and squid in the freezing depths. But no discussion of Antarctic wildlife would be complete without mentioning the largest animals to ever live on Earth: the blue whales. These oceanic giants migrate to Antarctic waters each summer, drawn by the immense swarms of krill that flourish beneath the ice. Blue whales can grow up to 100 feet, 30 meters, long and weigh nearly 200 tons, That's more than 30 elephants combined. Despite their massive size, they feed on some of the smallest creatures in the ocean, krill. Using their baleen plates, they filter up to 4 tons of krill per day, supporting their enormous energy needs. And speaking of krill, these tiny, shrimp-like creatures are the foundation of the Antarctic food chain. Without them, every predator in these waters, from penguins to whales, would struggle to survive. The health of the Antarctic ecosystem depends on them. Antarctica's wildlife is a testament to the power of adaptation. From the tiniest krill to the mighty blue whale, every creature plays a role in maintaining this fragile, frozen ecosystem. But as climate change alters the Antarctic landscape, these animals face new challenges. The melting of sea ice, shifts in krill populations, and rising temperatures are already reshaping their world. As we continue to explore and understand this icy wilderness, one thing is clear. Antarctica is a place of resilience, survival, and awe-inspiring beauty. And its wildlife, as tough as it is, may need our help to endure the changes ahead. Antarctica is more than just the coldest, windiest, and driest place on Earth. It's also a climate regulator for the entire planet. The massive ice sheets that cover this frozen continent are like a giant mirror, reflecting sunlight back into space and helping to keep global temperatures stable. But something is changing. The ice is melting, and not just slowly. It's happening at an unprecedented, accelerating rate. We are witnessing one of the most dramatic transformations in Earth's history. What happens in Antarctica doesn't stay in Antarctica. Its melting ice affects every ocean, every coastline, and every person on the planet. Today, we'll explore the causes, the consequences, and the future of a warming Antarctica. For most of human history, Antarctica's ice sheets have remained relatively stable. But over the past few decades, scientists have made a chilling discovery. The rate of ice loss has more than tripled since the 1990s. Let's talk numbers. Every year, Antarctica loses 150 billion tons of ice. That's enough to cover the entire state of Florida in 4 feet of water. Some glaciers are melting from below as warm ocean currents eat away at their foundations. Others are collapsing from above, breaking into massive icebergs the size of entire cities. And then there's the Doomsday Glacier, the Thwaites Glacier. The Thwaites Glacier, often referred to as the Doomsday Glacier, is one of the most unstable and rapidly melting glaciers in the world. Why is this so important? Because Thwaites acts like a cork holding back an even larger mass of ice. If it collapses completely, it could trigger a chain reaction, destabilizing the entire West Antarctic ice sheet. Scientists estimate that Thwaites alone could raise global sea levels by 3 meters, 10 feet. That might not sound like much, but imagine the consequences. Entire cities submerged, millions of people displaced, coastal infrastructure destroyed, and that's just the beginning. What's happening to Thwaites is not theoretical. In 2022, satellite images reveal that the glacier's underwater ice shelf is fracturing and warm ocean water is rapidly eroding its base. At this rate, parts of Thwaites could collapse within decades, not centuries. Antarctica holds 60% of the world's fresh water, locked away in ice. If all of it melted, sea levels would rise by 58 meters, 190 feet. That's not just a crisis. It's an extinction-level event for coastal civilizations. Let's put this into perspective. With just a 2-meter, 5-foot rise in sea levels, cities like Miami, New Orleans, and Amsterdam would face severe flooding. A 10-meter, 33-foot rise would submerge London, Shanghai, and Kolkata. And if we ever reached 58 meters, entire countries like Bangladesh, the Netherlands, and island nations like the Maldives would simply disappear. Even a small rise in sea levels can have devastating consequences. Higher tides mean more frequent flooding, stronger storm surges, and saltwater contamination of freshwater sources. Entire ecosystems would be thrown into chaos, and millions of people would be forced to relocate. Much of the melting isn't happening from above, it's happening from below. Warmer ocean currents are seeping underneath Antarctica's ice shelves, melting them from the inside out. This weakens the glaciers, causing them to fracture and collapse. And here's the scary part. Once ice shelves break apart, there's nothing stopping glaciers from flowing into the ocean faster. It's a feedback loop. The more ice that melts, the faster the rest follows. And melting Antarctica doesn't just mean rising sea levels. It disrupts weather patterns, affects ocean currents, and even changes the stability of ecosystems thousands of miles away. The situation may seem dire, but there is still hope. Scientists, activists, and governments worldwide are working to slow the melting and protect Antarctica's fragile ecosystem. But it requires global action. Antarctica is the canary in the coal mine for climate change. What happens here is a warning for the rest of the planet. The ice is melting, the seas are rising, and time is running out. But if we act now, if we commit to bold action, we can still protect this fragile wilderness and ensure a future for generations to come. The fate of Antarctica is not just about ice. It's about all of us. Antarctica isn't just a land of ice and extreme weather. It's a natural laboratory on a massive scale, one of the most important scientific frontiers on Earth. Scientists from around the world travel here to study everything from climate change to space exploration, from ancient microbes frozen in the ice to cutting-edge astrophysics. But working in Antarctica is no easy feat. Scientists here battle temperatures colder than Mars, relentless hurricane-force winds, and months of darkness during the long polar winter. Yet, despite these challenges, Antarctica offers unparalleled opportunities to understand the past, present, and future of our planet and beyond. Today, we'll take a journey through the fascinating world of Antarctic research, exploring how scientists are pushing the boundaries of human knowledge in the most extreme environment on Earth. Antarctica is home to around 70 research stations, operated by 29 different countries. Some are small outposts, manned by just a handful of people, while others, like the McMurdo Station, are bustling hubs with over 1,000 scientists and support staff during the summer months. Many of these stations remain operational year-round, enduring the harsh Antarctic winter, while others are seasonal, functioning only during the warmer summer months. Antarctica is a treasure trove of scientific knowledge, with research spanning multiple fields. Let's explore some of the most groundbreaking studies taking place on this frozen continent. Antarctica is one of the most sensitive barometers of climate change. Scientists here are studying how rising temperatures are affecting glaciers, ice shelves, and global sea levels. Ice cores extracted from Antarctic glaciers hold 800,000 years of climate history, helping scientists track CO2 levels and temperature fluctuations over millennia. The West Antarctic ice sheet is melting at an alarming rate, and research stations like Thwaites Glacier Camp are studying how its collapse could impact the world. Satellite monitoring from Antarctica provides real-time data on ice loss, helping predict future sea level rise. Scientists are even studying air trapped in ancient ice to understand how Earth's atmosphere has changed over time. Antarctica's harsh, isolated conditions make it one of the best places on Earth to simulate space missions. In fact, NASA and the European Space Agency, ESA, conduct Mars survival training in Antarctica. Concordia Station is often compared to a Mars base. Scientists living there experience months of isolation, testing how humans would survive on long space journeys. Ice-covered lakes like Lake Untersee mimic conditions on Europa and Enceladus, two moons that may host alien life beneath their icy crusts. Studying these lakes helps astrobiologists understand where to search for extraterrestrial life. The South Pole Telescope scans the cosmic microwave background radiation, giving us clues about the origins of the universe. Beneath Antarctica's thick ice sheets lie more than 400 hidden lakes, sealed off from the surface for millions of years. One of the most famous is Lake Vostok, buried under 4,000 meters of ice. Why are scientists so excited about these lakes? Because they may contain ancient life forms, microbes that have evolved in complete isolation for millions of years. In 2013, Russian scientists drilled into Lake Vostok and found bacteria unlike anything seen before, raising the possibility of unique life forms thriving in these extreme environments. If life can survive in Antarctic lakes without sunlight or oxygen, it strengthens the possibility that life could exist on icy moons like Europa or Enceladus. Buried deep under Antarctica's ice is one of the most ambitious physics experiments in the world, the IceCube Neutrino Observatory. What is IceCube? It's an array of over 5,000 sensors embedded in the ice, detecting neutrinos, tiny subatomic particles that travel across the universe. Why study neutrinos? Because they could help us understand supernova explosions, black holes, and the origins of the universe. Neutrinos are almost impossible to detect, but Antarctica's clear, dense ice provides the perfect medium to capture these elusive particles as they pass through Earth. The research happening in Antarctica is more important than ever as climate change accelerates. The data collected here will help us predict the future of our planet. As space agencies prepare for missions to Mars and beyond, Antarctica will continue to be a training ground for interplanetary survival. New technologies, including autonomous drones and underwater robots, are making it easier to explore Antarctica's hidden depths. Scientists are also working on eco-friendly research stations, ensuring that the pursuit of knowledge doesn't damage this fragile environment. Despite the tensions that exist in the world, Antarctica remains a rare example of global cooperation. The Antarctic Treaty ensures that this continent is used only for peaceful, scientific purposes. It is a place where scientists from every nation come together, united by a shared mission to understand our world, protect its future, and push the boundaries of human knowledge. Antarctica may be the coldest, most remote place on Earth, but it is also a window into the past, a laboratory for the present, and a key to the future.